At the beginning of the Big Bang of modern AI, we recognized the need to create a new kind of computer for a new way of developing software. Software will be written by software running on AI computers. This new type of computer will need new chips, new system architecture, new ways to network, new software, and new methodologies and tools. We've invested billions into this intuition and has proven helpful to the industry. It all comes together as DGX, a computer for AI. We offer DGX as a fully integrated system, as well as offer the components to the industry to create differentiated options. I'm pleased to see so much AI research advancing because of DGX. Top universities, research hospitals, telcos, banks, consumer products companies, car makers, and aerospace companies. DGX helped their AI researchers whose expertise is rare, scarce, and their work strategic. It is imperative to make sure they have the right instrument. Simply, if software is to be written by computers, then companies with the best software engineers will also need the best computers. We offer several configurations, all software compatible. The DGX A100 is a building block that contains 5 petaflops of computing and super fast storage and networking to feed it. DGX Station is an AI data center in a box, designed for workgroups, plugs into a normal outlet. And DGX SuperPOD is a fully integrated, fully network optimized AI data center as a product. SuperPOD is for intensive AI research and development. NVIDIA's own new supercomputer called Selene is 4 SuperPODs. It is the 5th fastest supercomputer and the fastest industrial supercomputer in the world's top 500. In total, NVIDIA is operating an equivalent of 18 SuperPODs. We've invested a couple of billions of dollars in computing infrastructure to do basic research in AI, to develop AI software that goes into our products, and to develop our library of pre-trained models. We have a new DGX Station 320G. DGX Station can train large models, 320 gigabytes of super fast HBM2E connected to 4 A100 GPUs. Over 8 terabytes per second of memory bandwidth. 8 terabytes transferred in 1 second. It would take 40 CPU servers to achieve this memory bandwidth. DGX Station plugs into a normal wall outlet, like a big gaming rig, consumes just 1500 watts, and is liquid cooled to a silent 37 dB. Take a look at the cinematic that our engineers and creative team did. This is the processor board, and it's exactly the same one that goes into supercomputers. This is a true server with baseboard management controller for remote management. And it's heavy. These are solid copper, billet machined, special cold plates with super fine pitch fin stacks. These plates are brazed, joined to copper tubing in a hydrogen furnace to create flux-free joints. This right here, this connects to a phase change refrigerant cooling system. DGX can store and release significant amounts of heat energy by changing phase from liquid to vapor and back. Unlike typical liquid cooling systems, DGX is closed-looped and requires no maintenance. Imagine if Alex, Ilya, Jeff Hinton had a DGX station in 2012 when they won ImageNet. 10 years ago, they used a GeForce GTX 680. 3 teraflops, 2 gigabyte frame buffer at 150 gigabytes per second. DGX Station 320G is 400 times the compute with Tensor Core, 100 times the memory capacity with NVLink, and 300 times the bandwidth with HBM2E and 2.5D CoWoS packaging. A CPU cluster of this performance would cost about $1 million today. DGX Station is $149,000, the ideal AI programming companion for every AI researcher. Today, we're also announcing a new DGX SuperPOD, 3 major upgrades. The new 80 gig A100, which brings the SuperPOD to 90 terabytes of HBM2 memory, with aggregate bandwidth of 2.2 exabytes per second. It would take 11,000 CPU servers to achieve this bandwidth. About a 250 rack data center, 15 times bigger than the SuperPOD. Second, SuperPOD has been upgraded with NVIDIA BlueField-2. SuperPOD is now the world's first cloud-native supercomputer, multi-tenant shareable, with full isolation and bare metal performance. And third, we're offering Base Command, the DGX management and orchestration tool used within NVIDIA. We use Base Command to support thousands of engineers, over 200 teams, consuming 1 million plus GPU hours a week. DGX SuperPOD starts at $7 million and scales to $60 million for a full system.